very special thanks, and I have to say that I was very honored of this kind invitation. And in addition to that, some of you may know that Switzerland has a very special place in my heart, because 2005 I was working in EPFL, and back then I was also expecting my son. So basically, like, we always have a bit of Swiss spirit in our family, and we are very happy about that. But regarding this talk, I will firstly kind of like introduce our work, which we have been doing in collaboration with my colleague, Bram de Wiever from the University of Kent, in which we have been investigating, based on the large-scale assessment data, the kind of like skill differences between the adults with the vocational education and training background on the problem solving in the technology-rich environments. And I think that that's one of the key kind of like issues regarding the digitalization, that how well people are able to cope with the novel technologies and kind of like adapt to the needs of the changing world. And in addition to that, in the later phase of my talk, I will focus on the novel methods and technologies that we are currently working with together with the kind of workplaces. And during that part of the talk, also my colleague Joni Lamsa will introduce the heart rate variability measurement kind of like work that we are currently doing at. Okay, but as a background, what is kind of like featuring really the work that we do here in the University of Jyväskylä in the area of technology enhanced learning. We started out kind of like how the technologies can be utilized to help out learners to learn better. For example, within those learning games that were mentioned, kind of like what kind of learning situations could be scripted within the game environments to enable the specific learning situations that are hard to achieve, for example, in the vocational education training. On the other hand, we are realizing that nowadays our interest also have to shift more and more towards like what the increasing technological society actually means for the learning and professional development. Because nowadays we cannot anymore think of the technologies as a tools or aids only that are kind of like enabling certain specific learning or interaction processes. We should really kind of like also be very well aware of the fact that because the technologies are coming into the vocational kind of workplaces and also to the vocational education and training, we also have to adapt our ways of behaving and kind of like the learning and teaching activities that we kind of like target for the vocational education and training. So basically, our research always starts with the starting point that this rapidly changing world is actually reshaping learning and professional development. And because of that, we also have to reshape the vocational education. And what is needed to do that? We think that we need to have a general picture. So what is kind of like the state of art, what is happening at the European level or worldwide regarding the needs and skills of people with the vocational education and training background. And on the other hand, what is happening on the working life, what kind of like continuous education is needed. On the other hand, that's not enough, because when it comes to the actual working situations, then we also have to develop a very deep understanding of the learning and interaction processes and how do those processes actually occur and unfold over time. Because like when we think, for example, the research on the collaborative learning, it used to start out with the approach that different kind of settings were firstly compared. For example, that there was a technology enhanced setting and it was compared with the non-technology enhanced setting. And rather soon the research community kind of like realized that, okay, this is not enough, because in the most cases it's not possible to choose between like, okay, we do this with the technology or without the technology. It's not even relevant to choose in many cases because technologies can be used for the specific kind of learning situations and give specific kind of added values. And after that, the research interest kind of like shifted towards kind of like measuring, for example, or kind of like building better understanding, for example, of the processes, for example, knowledge construction processes. And it was very typical that it was kind of like different kind of methods, kind of like the processes were evaluated, for example, that there is this much of the high knowledge construction process within the kind of like a classroom situation or so on. But nowadays we are understanding that it's not so kind of like it's not enough if we know like how much of the high level knowledge construction occurs. We have to also understand how it unfolds over time. And Joni, who is going to talk later, did his PhD exactly on that question, like how to different kind of like learning processes unfold over time. And that's critical when we think of the teacher-student interaction, for example, that how to enable high-level knowledge construction in the situation when students are actually kind of facing the problems. And when it comes to the working life, what is happening, it's like there is a lot of talk, and you already know a lot that there is this structural change. And basically, especially on the industry in the Europe, it's like moving from the mass production to the flexible production methods. For example, within the different kind of like companies, they have to be way more flexible, way more adaptive than previously, and kind of like quickly move with the changes. For example, the COVID situation, we can see the clear shift between the companies who were able to adapt to this radical change that happened in the worldwide, and then some other companies were kind of like suffering much more. At the same time, jobs are also disappearing. For example, at the industrial sector, like they are moving to the Eastern countries, or the other option is that it's more automatized. And on the other hand, it's also kind of like creating a new job, because when somebody was trained, for example, 30 years ago, nowadays probably the kind of like description of the profession is already very different. And when there are, for example, the cut downs, people really have to kind of, if somebody has been working in the paper industry, which is one of the main industries in Finland, and if the kind of like whole factory is closed down, they are kind of like in the identity position that they really have to figure out that what kind of skills I do have and how do I adapt to this change if I don't want to move to the other side of Finland or for the other country, because those factories are not put up in the second. But what is very common for the almost any professionals is that like more and more people with the vocational education and training background have to handle and produce new kind of information, which is coming from the different sources, as well as solve very complex problems together with the other professionals who are not exactly from the same field necessarily, not from the same country even. So therefore, it's very important to understand that what is the state of art regarding the problem-solving skills among people with the vocational education and training. And we realized like 10 years back that there are a lot of studies on this, but most of those are kind of like small, specific experiments. And the critical question was that even though the kind of like case studies, I really like them, and I think that they are very, very important way of like produce new knowledge of understanding how something is happening, for example. But there was a critical question that there was no large scale kind of like assessment data or no large scale assessment studies regarding like what is the state of art when we are kind of like evaluating, for example, the vocational education and training and the needs at the European level. It's very important that we know what kind of skills people do have and what kind of skills they should have. And therefore, we applied the large-scale assessment data called PIAC, which has kind of like a very large background questionnaire. But in addition to that, the specific feature of PIAC is that all the adults have been taking a test. And it's like more than 40,000 participants in Europe who has actually participated in the test. So it's a very, very kind of like gives a rather nice overview what is happening. Some people call it a bit like an adult's PISA. And it kind of like, it doesn't give you the details. On the other hand, it gives you an overview. And how the problem solving is defined is that problem solving in technology-rich environments involves using digital technology, communication tools, and network to acquire and evaluate information, communicate with others, and perform practical tasks. And the first PIAC problem solving survey focused on the abilities to solve problems for personal, work, civic purposes by setting up appropriate goals, plans, assessing and making use of information through computers and computer networks. And as we can see by the definition, the PIAC test was not like a very specific test for the engineering people. It was more kind of like testing the general abilities to solve problems, use technologies for those problem-solving situations. And in short, the skills were defined: strong, moderate, weak, and at risk. And basically, the at-risk people are the ones who were not able to kind of like take the pre-test or pass the pre-test of the PIAC, or who kind of like said that they don't take the problem-solving test at all. So those people were defined at risk. And then there were those weak, moderate, and strong performers. And we have been writing a different kind of publications based on our analysis of the PIAC data. And we started out at the European level, and we basically like seeked what is the state of art. And after that, we focused the Finnish data, since we were kind of like investigating how the data can be used, and especially factors explaining variations regarding the problem-solving skills. And then, as we noticed that there are variations, we actually, in the third article, we focused on the people who have vocational education and training background and very strong skills. So we basically like wanted to know what makes them strong. And in addition to that, we have focused also on the informal, non-formal, and formal learning regarding how those are associated with the people's skills. And then we did a bit similar studies for the higher education adults, and we found out that the people working in the educational fields, they have a lower problem-solving skills in technology-rich environments than the others. So because of that, we also did a further investigation of the teachers' problem-solving skills as well as their digital competencies. And what the situation actually then looks at the European level, we investigated that what is the level and distribution of problem-solving skills for the adults with vocational education and training, and how is the level and distribution of problem-solving skills for adults with VET related to the adults with other educational background. And unfortunately, we found out that there is a tendency to have a low problem-solving skills in all 11 countries that participated in the PIAC. And only small minority of the VET adults actually score on that highest level. And more than 11% of the VET adults are actually at risk regarding their skills. And as we all know, in Europe, the vocational education and training, it's kind of like organized in the different ways. There is this school-based approach and then work-based approach. And it was in our interest to find out whether there are differences between the approaches. And as you can see here, it's very interesting that even though there are huge kind of like differences within the countries, the approach is not associated with, with the differences. So basically, based on the PIAC study, you cannot not claim that it's better to train on the workplaces or it's better to train on the school-based, at least based like regarding the problem-solving skills in technology-rich environments. And then we also took a look at what is the difference between kind of like higher education adults and VET, and regarding Finland, we found a very critical thing that we actually have a very high performance in the higher education, but like below the average in Europe. And then we kind of like, because of that, we wanted to find the indicators for the problem solving skills differences. And we see that what is the level of the distribution within the adults with vocational education, and how is the level and distribution related to the adults with the other educational background. And then we seek that what factors explain the variations, and what are the differences between the problem-solving skills with the adults and other educational background in predefined age group before and after controlling the effects of the statistically significant background factors. And we built up different kind of models that started out with the theoretical assumptions as well as empirical support. And what we did was actually that we looked at the socio-demographic factors, because we know that those are always kind of like associated with the different skills based on the previous studies and the literature. And then, since the work-related learning taking place at work, through work, and for work, it's a largely investigated area. And we know that it's very important. So we took the one cluster that focuses on the work. And nowadays, since the informal learning, everyday life learning is kind of like increasingly highlighted, we also focused on the factors that are associated with the everyday life learning. And as an outcome, we got the problem solving skills. And this is just explaining a model. And we found out that there is this tendency to have the lower skills. On the other hand, it was very interesting to see what are kind of like factors explaining the variation in problem solving skills. We can see the very kind of like typical ones: age, education, occupation in years, and then gender. So that's something that probably everybody can kind of like figure out, or at least say that, okay, that was very easy to guess. Yes, but the interesting part comes when it comes to the work-related learning and everyday life learning, because we found out that everyday life learning is actually like more associated with the skills than work-related learning. And that kind of like leaves a lot of space also for the speculations and for the future studies as well, that how to actually make the work-related learning the most efficient. And regarding the work-related learning, especially the use of the ICT skills at work seem to be associated with skills, which is quite understandable, and learning at work. And regarding the everyday life learning, the use of numeracy skills, use of ICTs, and reading. And this reading is also very interesting. But what is also the most interesting finding is probably it's not what is associated, but what is not associated, and that's adult education and training. So basically, we found out no association between the participation of the adult education and training and the problem-solving skills in technology-rich environments. And of course, we have to be very careful what kind of like conclusions we can make out of this. And basically, we have to say that either it doesn't target to the specific kind of skills, or it fails. But this is completely impossible to say based on our results. And when controlling the effects of the kind of like the background factors, then the picture then exchanges quite dramatically. And in our fourth study, we focused on those who have a very good skills. And in short, the strong performers seem to be younger, more often male, and more often in the skilled occupations. And that's also kind of like interesting because, of course, we cannot exchange this gender, but regarding the vocational education and training, we should really kind of like focus on how to enable problem-solving skills learning in, for example, for the female students, because that's something we can definitely influence at, or at least try to. And active skill use at work seem to be more common with the people who have stronger skills, especially with the numeracy, ICT, reading and writing. And finally, regarding these large-scale results that we got, this everyday life learning seems to be very interesting because it's like more and more highlighted nowadays, and internet and related applications are used a lot for the leisure activities, and it seems that adults' educational background is associated how technologies are used in everyday life. And what I mean with how technologies are used for the future, it's very kind of like critical that how to activate the kind of like intellectual use or kind of like knowledge construction, for example, through the work, through the internet or other kind of technologies, instead of like very passive use, for example, just listening to something, but not kind of like doing anything by yourself. And now I'm moving to the second part of the talk, in which we are very excited, since we are working with different contexts. We started out with the vocational education and training and kind of like traditional schools context. But nowadays we are collaborating very closely with the different kind of working life settings, and especially we have like two main collaborators. We do a lot of work together with the local hospital over here, and especially regarding like the healthcare education and nursing and different kind of like jobs on that discipline. And most recently, we have been also collaborating with Finnair regarding the flight simulators and the pilots kind of like flying. And Minna Ruoranen is already a PhD based on our collaboration with the local hospital, and she is now working kind of like partly at the hospital and partly in our university as a postdoc. And in addition to that, Virpi Salo is also doing her PhD regarding the emotions in the nursing and students' collaborative simulation context. But what I'm giving a bit more kind of like introduction now is the Emilia's work, and Emilia is a PhD student, and she's using a VR in the healthcare context. And we are currently kind of like doing the review article regarding the state of art, how the VR can be applied within the healthcare education, because those different kind of like healthcare kind of needs are very, very clear, because a lot of things you cannot rehearse with the actual people. So because of that, the technologies are really coming in, and they have been always kind of like applied in the different forms. On the other hand, we have to be realistic that since for example, the VR, it's kind of like rather expensive to develop, and there is a lot of hype. As I mentioned earlier regarding those case studies, it's quite often the kind of like the starting point that the different kind of environments are described in itself, on the other hand, and then the kind of like experiences that, okay, I felt that it was beneficial for my learning. But on the other hand, for the future, it's also very important to develop kind of like deep level understanding of the learning processes and knowledge construction processes within these technological environments. And in Emilia's case, we had the research design of 16 participants, and we collected the different kind of data. We collected the heart rate variability data, and then the video and audio recording of the simulation. And then we also conducted the semi-structured interviews. And before the actual tryout with the VR, we had the background questionnaire for all the participants. And then for the case with the pilots and our collaboration with the Finnair, we had the very similar kind of like research design in a sense. We also measured the heart rate variability, and then in addition, for the case with Emilia and colleagues, we used the eye tracking as well. So basically, we tracked where do people look at, and then we also had the same kind of like semi-structured individual interviews in this case, and we had the kind of like background questionnaire on the very beginning. And now I turn the floor for Joni. Please go ahead regarding the heart rate variability, how we have been using that kind of data.
Yes, so special thanks, Raija, first of all, for inviting me to give this brief introduction to this topic. So I'm Joni Lämsä, and I work as a postdoc researcher at University of Jyväskylä in Raija's research group. And in this short talk, I will introduce that how we have applied heart rate variability measurements to study these pilots' virtual reality training and from the perspective of cognitive load. So in particular, for example, in the pilot's training, in which the essential part of their competence is to deal with high uncertainty in time pressure, this cognitive load theory could be a useful framework for designing training, because its aim is to avoid cognitive overload even in those very kind of challenging and rare circumstances. And here we can see the different types of loads that require our working memory capacity. So first of all, there is the kind of the learning task that, for example, pilots are trying to solve in those simulators when they are, for example, challenging weather conditions, high crosswind or very bad visibility, for example, it produces this kind of intrinsic cognitive load. But also learners or pilots' expertise is highly associated with this load, because when you have much experience, you do not have to process every separate piece of information, for example, that the simulation or the cockpit environment produce, but you have those kind of schemas that help to produce that kind of overall picture of the situation. And then there are those other types of loads, this extraneous load. So for example, how we design those training, what kind of interaction there is between pilot and co-pilot in the environment, and what kind of learning environment is. And when researchers and teachers or trainers want to measure this cognitive load and understand that how to design, for example, more effective training for future purposes, there have been different types of indicators. So these kind of subjective measurements, self-reports or interviews have been very, very widely used, and those are very useful. But one challenge in those is that those do not provide that high kind of temporal granularity. So it's difficult to observe kind of variation in the cognitive load. Or if you ask all the time that how high load the people are experiencing, it's not that practical way of doing it. And because of that, and because these kind of heart rate variability measurement devices are becoming more and more affordable, novel measurement tools have been developed to capture kind of the variation, for example, in the cognitive load. But of course, the challenge is that the variation in our heart rate, for example, may be induced by very different factors, and it may be very difficult to pinpoint that Was it, for example, the change in the weather conditions in the simulator that produced the variation in the heart rate? But that's something that we have investigated in this project in collaboration with Finnair. And this time series here shows the heart rate of one pilot during this about 45-minute simulator training. And from this time series, when we look at it, we see one added value that these kind of objective measurement devices can provide, because we can identify those kind of critical moments that emerge from that time series data. We see those light gray fading moments 3 times during the training. And when we looked at the kind of the schedule of the training, we noticed that those peaks in the heart rate occurred during approach and landing scenarios. So during that training, the pilots approached and landed to the airport three times. And during those moments, we observed increase in heart rate and decrease in heart rate variability when compared, for example, to that baseline flighting that have been marked with darker fading. And this was for one pilot. And when we investigated whether we can find similar patterns from the whole sample, we indeed observed that this red line that shows the heart rate, it decreased from the scenario to scenario. So in the first one, the heart rate was the highest, and in the third approach and then landing scenario, it was lowest. And the opposite was observed for those heart rate variability parameters. So the heart rate variability increased from the first to the third scenario. And this was a bit surprising finding, because that training was designed in a way that the task difficulty was supposed to increase over time. So in the first approach and landing, there was only a light wind, and it was kind of the basic scenario for the pilots that they had practiced a lot. And in the final, or in the third approach and landing, there was a heavy crosswind. And in addition to that, that kind of fault, rather rare fault situation occurred during it. And still that kind of trend was observed. And then we started to look at that, how did the pilots reflected those simulator sessions in those interviews. And we found that, okay, there may be some sense in our results in a way that both expert and novice pilots highlighted that this kind of complex simulation environment, it requires some time to get used to it. And also the expert pilots mentioned that it takes some time, for example, to identify those parameters and instruments that provide kind of essential information during those approaches and landings. So that was the first kind of finding from the interviews. And the second one in the next slide was what we observed, especially among the novice pilots, that even though that training was designed by the expert flight trainers from Finnair, and even though the task difficulty was supposed to increase over time, especially the novice pilots might not notice that increase in the task difficulty, but they perceived that, okay, those were, for example, the second scenario was as difficult as the first one. And that's problematic from that perspective, that this flight simulator training is really expensive. There are limited time resources that are that can be used for that training, and if we do not use that time effectively, it may be challenging. And here are kind of 3 points that we have identified that should be considered in the future when these kind of physiological measurements, for example, are used in studying the training. So first is that how do we interpret those changes in the heart rate or heart rate variability parameters? Are those different parameters sensitive to the different types of cognitive load, intrinsic or extraneous cognitive load, for example? And also the third point relates to that cognitive overload perspective, that do we have that kind of parameters that would capture when the cognitive overload occurs, because it can be very rapid moment, but it can have a critical consequences if those kind of rapid cognitive overload moments occur during flighting. But this was my brief overview, and Raija will continue what we have found out from that same context by using eye tracking data. But thank you from my side.
Thank you very much, Joni. And if you have questions in the end, you can also direct them for the Joni, of course. And in addition to the heart rate variability data, we also collected the eye tracking data. And as we mentioned earlier, there are kind of like two sets of pilots. We had the novice pilots and then the experienced pilots. And currently we are investigating like that, what can the eye tracking data actually tell about the professional learning, and what kind of case-based indicators can be applied and how reliable they are. On the other hand, as a starting point, we are kind of like very optimistic regarding the possibilities, because we have done a lot of discussions with the Finnair and also with the healthcare sector people, and they define that it's actually very hard for the instructor to see what the one or the student is actually looking at. And for that we see a lot of added values of the eye tracking data. Simply firstly kind of like to see what are they looking at and what is the focus of attention. For example, if there is a specific problem solving skills, it's very interesting to see whether the focus is on the point that it's critical or kind of like useful or helpful regarding the solving the problems. And in addition to that, regarding experienced and novice people, it's of course like possible to compare those two kind of like pilots. And for example, here we can see that PFD is something that it's very crucial for the flying, because they see a lot of information on that. And then there is a window. It was kind of like landing situation in which these two experts about, and we can see the difference between the experienced and the novice landing. And in addition to that, we have been using the hidden Markov models to kind of like find out the differences that are not direct from the data. And our third example, how we have been using the eye tracking data, is we have been investigating the differences within the group. In this case, we have focused on the experienced pilots, and we can see that this is also very interesting, because like at the same flight situation, the ID1 actually only looks at the 4 patterns of the, like we call them areas of interest, because there is kind of like a possibility to tag specific parts of the kind of like airplane on the beginning, and then we are able to identify like how many of those and when people are looking. We can see the timeline over here, and then we can see how much time they used, for example, in this PFD. And we can see the difference between the ID1 and ID7, that actually the ID7 is looking way more of those areas of interest than the ID1 is looking in this case. And we are currently working on the state of art, that we are trying to kind of like build a general picture of that based on the interviews and then the heart rate variability that Joni was describing, and also the eye tracking. And we are hoping that these kind of like multimodal data are very good for the strengthening the VET, not kind of like replacing the usual ways of kind of like handling the data, for example, the interview data or the observation data, but actually like to add the layers in which we are able to understand the the time and kind of like how the learning and interaction processes unfold during the specific time moments. And through that, we are hoping to find the critical moments that the instructors would be able to kind of like focus their attention to. And regarding the future, these kind of technologies are coming into the machines. We know that already from the China, there is a lot of examples, and also increasingly into Europe and US. And what is interesting and important is kind of like the collaboration, not between the people only, but actually like the how do the machines develop and what kind of like human machine collaboration is needed, and how these kind of novel technologies can enable that kind of collaboration. For example, if the machine is kind of like identifying that specific worker would have problems with the specific kind of problem solving situations, there could be kind of like intellectual aids that would be added in them. On the other hand, we are realizing that machines will not, hopefully, will not kind of like replace people, but we have to find the optimal bond between the human and emotional intelligence, and with the robots and machine and advances of the handling the big amounts of data. But as a conclusion, in the future, workers must be able to quickly take newer technologies and solve problems. That's probably very generally agrees. On the other hand, when we are investigating this, we have to remember that workers are actually a heterogeneous group, and their needs can vary among the professionals. So because of that, we really think that those kind of case studies with specific methods are very useful and valuable for the future of the vocational education and training. But in addition to that, there is a need for developing new ways to empower professional learning and professional development. And we think that eye tracking and hardware, for example, eye tracking to identify successful or unsuccessful operations is very useful, for example. On the other hand, we are realizing that in the future, the very traditional kind of long tradition, we definitely have to take the advance of the research done already in the workplace learning, everyday life learning, for example, in the agency and emotions, because those can be emerging in the different kind of vocational education and training professions, as well as individual development and professional communities, the kind of like how those evolve and develop, as well as the potential and limitation of the novel technologies within this context. And as a conclusion, we think that this area of technology enhanced or technology developed vocational education and training, it's kind of like tackling with the three main kind of approaches. Since the technology has multiple roles, we cannot say that, okay, it's a good or it's a bad thing to bring in the technologies, because all our world is kind of like surrounded with the technologies. We have to adapt on those changes. On the advances, it can support learning, different kind of learning activities, learning processes. And then there is a third level, and it's the data analysis level and awareness tools that can be developed to enhance the vocational education and training. And I definitely haven't been thinking of these ideas all on my own. So in the end, I would like to thank all the researchers in our research group who have done very, very extra good work within this. And of course, like this has also been done in the close collaboration with the international colleagues, for example, with Farm de Viver. And in addition to that, I've been working with Alberto Cattonia from Switzerland. So I would like to say special thanks to Alberto. And I think it's about 45 minutes, so it's time for the questions and remarks, please.
Thank you very much for this interesting talk. You're right on time.